All right, Megan, can you hit the back light, please? And wherever you're going to keep your notes, take those out and run through this fairly quickly. Well, today's Friday the 13th. Scary. We're going to do section 4-6 today. And section 4-6 is going to mainly deal with isosceles triangles, which we defined defined it way back in section 1, isosceles triangles. So we're going to do a lot of this with pictures today instead of writing all the words out. The first thing we have to know is what an isosceles triangle is. And hopefully you remember back to section 1, isosceles triangle is when two sides are congruent to each other on the triangle. So it's going to look something like this. And then there's some parts of the triangle that we need to know. On an isosceles triangle, the two sides that are congruent to each other, we call each of those a leg of the triangle. And then the side that's not congruent is called a base. Then we'll see if I can do this without making too much of a mess. These two angles here that are formed by the base and the leg are called base angles. The angle on the top, well, on top of this picture, the angle that's formed by the two legs is called the vertex angle. So those are words that kind of show up in the theorems and postulates that will come up in this section. So the words we kind of want you to know so that you understand what these theorems are telling you. All right, the first thing we have is a theorem here. And this theorem we're going to do kind of side by side because we're going to have a theorem and we're going to have its converse that both work. So on the left here, I'm going to do what's called the isosceles triangle theorem. And I'll try to do this with pictures again. So we'll start with an isosceles triangle. And once again, to be an isosceles triangle, we need two congruent sides, which we call the legs. And here's what the isosceles triangle theorem says in words. It says if two sides of a triangle are congruent, then the angles opposite those sides are congruent also. So in our picture here, we have these two sides congruent to each other. And what this allows us to do is we can kind of go across to the opposite angles and say that they're congruent to each other. That's your isosceles triangle theorem. And then we're also going to have the converse of that. Converse also works. Converse is where you do it backwards. And once again, I'm going to do this with pictures rather than writing out all the words. So over here on the isosceles triangle theorem, we started with two sides being congruent. and then the opposite angles ended up being congruent to each other. On the converse, we're going to start with two angles being congruent to each other. And then I'll read the words to this, and then we'll show you in the picture what it's saying. The converse says if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. So if the two angles are congruent, then now we can go across to the opposite sides and say that those sides are congruent. So this theorem works both ways. If you have two sides congruent, then their opposite angles are going to be congruent. If you have two angles congruent, then their opposite sides are going to be congruent. And then we have two more statements. These are called corollaries. A corollary is a statement that you can prove using a theorem by using a theorem. We're just going to kind of approach it the same way we do with theorems and postulates. It's just a statement that's going to be a true statement, something we know is true. So our first corollary, I think I'm going to spell this wrong again. I always spell corollary wrong. There's only one R in corollary. This corollary is going to be numbered corollary 4.3. And this one I am going to put the words on here just so you can see where this is going. It says, oops, it's supposed to be an A. It says a triangle is equilateral if and only if it's equiangular. So obviously we've got some vocabulary words in there we have to make sure we understand. And again, these vocabulary words go back to section 1 when we defined our different types of triangles. First one is an equilateral triangle. Equilateral triangle is kind of like isosceles. Isosceles, you had two congruent sides. With an equilateral triangle, all three sides are going to be congruent to each other. And then equiangular means all three angles are going to be congruent to each other. So here's what this looks like in a picture. Let's say I have a triangle. And this corollary says the triangle is going to be equilateral. It's going to have all three sides congruent if and only if it's equiangular, where all three angles are congruent to each other. So essentially it's saying if we can get all three angles congruent to each other, then just like what we did before, if we go across, these sides across from them will also all be congruent to each other. So if it's an equiangular triangle, then it's also going to be an equilateral triangle. And then we have one last corollary, which I think you guys can come up with on your own. This one's corollary 4.4. And we'll do the words first again, and then we'll see if we can finish it off. And we'll kind of piece this one together with a picture. Starts off by saying each angle of an equilateral triangle, and then we have to finish it. So let's start with an equilateral triangle. Equilateral triangle we know is going to have all three sides congruent. And then let's go back to what we did on that last corollary. Last corollary, we said if all three angles are congruent, then all three sides are congruent. Now we have all three sides congruent. If all three sides are congruent, what do you think we could say about all three angles? They're congruent also. So same thing's going to happen here. The angles across are all going to be congruent to each other. And then let's take it even a step further. If we add up all three angles in a triangle, what do we get? What'd you say? 180. If you add up all three angles in a triangle, you're going to get 180. If all three of those angles are the same, what would each angle have to measure? All three of them are going to add up to 180. They're all the same. What would each angle have to be? It's going to be 60. If you take 180 divided by 3, you get 60 degrees for each of these angles. So now, anytime we have an equilateral triangle, we're going to know that each angle is going to be 60 degrees. So that's how we finish this one off. Each angle of an equilateral triangle measures 60 degrees. All right, then we've got a few examples to show you how this works, kind of what you'll see on tests and quizzes when it comes to these types of problems. Let's call this one letter A. And on letter A, let's start with our picture. We have a triangle. It's triangle PMN. And in the picture, they're going to tell us that angles P and M are congruent to each other. And they're going to give us two things in here. Angle N is 120 degrees. And MN is going to be 11 meters. They're going to ask us to find two things. They want us to find the measure of angle M. And they also want us to find the length of PN. So a couple things to answer here. It really doesn't matter which order we find them. If you look at it and one of them kind of stands out to you, you can do either one first. I'm going to go with PN first because this one kind of stands out to me. When I look at this picture, I see an equilateral. I see a triangle with two congruent angles. And if I follow across those congruent angles, the opposite sides will be congruent to each other. So if this side's 11, this side's also going to be 11. So PN has to be 11 meters. And there's one of our answers. The other one we need to find is the measure of angle M. And this goes back to what we just talked about. If you add up all three angles in a triangle, you get 180. I know one of the angles is 120. So let's take 180 minus 120. That's going to leave us with 60 degrees for the other two angles. And those other two angles are the exact same thing. If those two angles are the same and they add up to 60, what does each angle have to be? 30. So angle M that they want here would be 30 degrees. All right, that's our first one. Now the next one, instead of starting with two angles congruent, we're going to start with two sides congruent. So now we're starting with an equilateral triangle. And on this one, they're going to tell us this vertex angle is 80 degrees. And we have two sides. They're going to give us 4y minus 2 and 2y plus 2. And we also have an angle down here, which is 6x plus 8. And this time they're going to ask us to find x and y. And once again, it will not matter which order you find them in. If one of those jumps out at you, you know what to do with it. Go ahead and do that one first. So it really doesn't matter. When I look at it, I see y first. Because when I look at y, we have these two sides, which we know are congruent. They're 4y minus 2 and 2y plus 2. If those two sides are congruent, then these two lengths have to be equal to each other. Find y, we take 4y minus 2 equals 2y plus 2. Then we got to do a little algebra here. If you subtract 2y, you get 2y on the left. Add 2 to the right, you get 4. And if you divide both sides by 2, y is going to equal 2. There's one of our answers. But we still need to get x. We've got a little bit more work to do. X is in one of the angles down here. So we have to look at our angles. We have an 80-degree angle up here. And we know if we add all three angles together in a triangle, we're going to get 180. Now, the other thing we have to realize is we have an isosceles triangle. So we can do that thing again where the sides are congruent, then their opposite angles are congruent. So these two angles will be the same. And again, if you add up all three angles in a triangle, you get 180. This angle is 80 degrees. So if I start by going 180 minus 80, I have 100 degrees left for these two angles. And then there's a couple of different ways we can go about it here. I'll do it this way. If these two angles are both the same and they add up to 100, what does each angle have to be? It's got to be 50 degrees. So 50 degrees here, 50 degrees here. So the 6x plus 8 is going to be a 50-degree angle. So find x, we'll just put those two equal to each other. 6x plus 8 is going to be a 50-degree angle. And again, do the algebra. If you subtract 8, you get 42. 42 divided by 6 is 7. All right, any questions with that? Okay, one last one. This one's a little bit quicker. This time, we're going to have a triangle where all three sides are congruent. When you have all three sides congruent, we call that an equilateral triangle. They're going to tell us one of the angles down here in the left-hand corner is 5x. And the directions they're going to ask us to find x. And to do this one, it goes back to the corollaries we talked about. If all three sides are congruent, we know that all three angles are congruent. And we can even take it a step further than that. If all three angles are congruent, they're going to add up to 180. What did we say each angle is going to measure? It's going to be 60. So you've got 60 degrees here, 60 degrees here, 60 degrees here. Same thing, we'll just take this angle, 5x, put it equal to 60 degrees. Divide 60 by 5, and you get 12. That's kind of how these pictures are going to show up on your next test or quiz that deal with these theorems and postulates and corollaries. Does anybody need to see another of any of these types? Okay, so that will take you up to your next assignment, which is actually one you're going to do at home, page 289. Numbers 15 to 22. And you've got some time here in class. If you want to start that now, get a head start on that.